Topics in post-harvest technology. Ethylene, commercial applications. Field ripening of tomatoes. Processing tomatoes are harvested per a calendar schedule. Fruit from particular fields must go to a cannery or a processing facility on a particular day to ensure that the facility operates efficiently. Therefore, having the tomatoes ripen at the correct time is very important. When weather conditions are unfavorable, the tomatoes may be delayed in ripening, and this is where ethylene applications become important. Ethylene is used to promote ripening so that the ripening is both faster and more uniform. Fields are sprayed with a compound called ethylene, which is 2-chloroethylphosphonic acid. Ethylene is the common name for this chemical. Trade names are ethyl, fluoral, protrim, plus a host of others. This is the chemical formula for ethylene. The ethylene combines with hydroxyl ions to break down, releasing a chlorine plus the ethylene plus dihydrogen phosphate in water. Ethylene only releases ethylene under alkaline conditions at a pH of 7 to 8. These conditions are found within plant tissues. When you spray the ethylene on the plants, it's absorbed, goes into the cells, breaks down, and ethylene is released. You spray ethylene on the tomatoes about 1 to 2 weeks before harvest, when approximately 10% of the tomatoes are red. Tree fruit management. Ethylene may be used as a fruit thinner for apples and peaches, and to help loosen cherries to allow for a gentler, more effective mechanical harvest. The ethylene that's released promotes the formation of an abscission layer in the fruit stems, that is, the peduncles of the fruit, which allows them to more easily fall from the trees. Fruit ripening. Exogenously applied ethylene is used to promote a quicker and more uniform ripening of tomatoes, bananas, and in some cases, honeydew melons. Exogenous indicates that the ethylene is being applied from the outside of the fruit. It's not being generated from within the fruit. If it were, it would be referred to as endogenously produced ethylene. Here's a ripening facility where they are ripening bananas, and you can see how many cartons of bananas are being stacked in these very large ripening rooms. Another image showing the bananas stacked in the ripening room. Here are doors coming down to seal this section, and when all the doors are down, ethylene gas will be introduced into the rooms to ripen the bananas. When bananas are put on ships for transport, they're put on the ships green and unripe. This allows them to be transported with much less loss due to overripening, bruising, decay, or other factors. When they come to a port in the U.S., they are gassed with ethylene before they're put on trucks for distribution to retailers. The ethylene triggers ripening so that by the time the bananas reach store shelves, they are turning yellow. This photo shows the ripening rooms with the doors closed. Ethylene is being introduced into these rooms. Citrus fruit degreening. Exogenously applied ethylene may be used to degreen citrus fruit. Sometimes, due to weather conditions, citrus may be fully ripe internally but have a rind that is green or partially green. This can happen with lemons and oranges. This is important for marketing as the fruit will look unripe, making the fruit difficult to sell. However, since ethylene is a senescent hormone, the exposure to ethylene must be carefully controlled to prevent degradation of the fruit tissues, leading to a loss of quality. Degreening of citrus requires exposing the fruit to precise amounts of ethylene at a specific temperature for a specific length of time. Citrus degreening protocols will vary depending on the type of citrus being treated and where it has been grown. Summary points. Ethylene is used to ripen tomatoes in the field. Ethylene is also used to increase the ripening rate and ripening uniformity of harvested tomatoes, bananas, and honeydew melons. Ethylene is used to thin the fruit load of apples and peaches and to degreen citrus such as lemons and oranges.